Okay, welcome, boys and girls. All right, so this is quadratic word problems. So this is all review from Algebra 1. So hopefully you remember some of it. I'm gonna be honest, this is one of the hardest topics to teach. I'm gonna teach it a little bit differently because now we're doing it online. Here's the biggest thing, right? You saw the video. So quadratic functions is used for a lot of different things, but for the most part, you're gonna like this, right? You got a ball or something and you're throwing it, or you got a big old cannon, blah blah. That's gonna look bad. You got a big old cannon. I'm just gonna draw that part, and you're basically gonna project out. You're gonna throw something. Maybe you're gonna throw it straight up and it comes back down. That's still a parabola. Maybe you want to see how long it takes. How high does it get? When do you throw it? When does it get back on the ground? What if you're here and you're on a tall building, and so you're going to throw it. You're going to throw it from that building, and you're going to throw it. But even if you try to throw it straight out, it's still kind of going to go up a little bit before it comes down. What else? What if you're on the top of a building and you just let it go? What if you're on the top of a building and you throw it hard? So it's gonna have an initial velocity. If you throw it, it's gonna have initial velocity higher than if you don't throw it, if you just let it drop. So believe it or not, all this stuff that we've been teaching you comes in very, very handy if you want to predict certain things. So I'm going to give you a hint right here. You got a word problem, right? The biggest problem of a word problem is figuring out what the heck are they asking? What are they telling us? What is the important information? So the goal of this video is really because you know the rest, right? You know how to find the vertex. You know how to find the axis of symmetry. You know how to find the x-intercepts, the y-intercepts. You know all of that. Now what you need to know is, in the real world, they're not going to say, hey, what's the y-intercept of this, blah, blah, blah. And it's so weird that they actually have an equation. So I'm going to give you another hint. On the test, we are going to give you the equations. Okay, you just need to analyze, like, what the heck. So in the real world, same thing. I'm some bozo standing at the top, blah, blah, blah. I throw a ball. I don't know what that equation is. My biggest thing is like, well, how is this going to help me? Because I'm never going to be able to know how they got this equation. Here's where they got the equation. Bam. I forget exactly what that one is, but sometimes that and that are the same thing. The most common ones they use when they use an actual projectile one, they might use that. They might use this. And I think the other one is -8. So basically this number stands for the gravity. This one stands for the initial height. This one stands for the initial velocity. So this one can change. I don't know why you got 16, but that one can change. Usually this one and this one, why is it sometimes -16? Why is it sometimes -32? Because it depends on what units you're using. Are you using metric units or are you using standard units? Just so you know, you might see it again in physics if you take physics. You see this again, and I kept wondering why they always look so similar, and nobody ever really, and maybe they told me and I just wasn't listening. But yeah, so we're going to give you the equation, but know that these numbers are super important. Remember, the y-intercept is always this number here if it's in standard form. So basically we're saying that for some reason, whatever's going on, we're starting at 480 something. So let's find out what's going on. Jason jumps off of a cliff into the ocean. All right, so there you go. There's the cliff. There's the ocean. Here's good old Jason. Don't do it, Jason. All right, so what does that mean? It means the cliff is 480 feet. T is the time in second. H is the height in feet. 480 feet high. Bam. Okay. Then what else? Where T is the time in seconds. That's going to be super important. By the way, notice the other things that are going to be important that we've talked about, right? We got the function name. h of t, right? You guys have seen all of that. H of t. What the heck does it mean? H is the height. So this is height and h of t, and we say t is time. So if you write all this stuff out, you're going to help yourself, right? You're like, I don't know, I got all these words, what do I... So it's saying h relative to time. So we want to know, basically, we want to know, so if he goes and so I'm just going to draw this, right? He's not going to go straight down like this. He's actually going to jump, because even if he falls, it's going to go, he's going to fall, but he's not going to fall straight down. Now, wait a minute. This is height, right? This is actual distance. But what are we looking at here? Are we looking at how far he jumps, or are we looking at the time? So it turns out this water isn't the distance of the water. It's not how far he jumps. This is time. That's why this part right here, that's why this part right here is super important. They're talking about time. Sometimes they actually might be talking about distance. They want to know how far he went. This time we just want to know how long did it take for him to hit the water, right? Acapulco, on vacation with some friends. So jumped off a cliff. I need that. Into an ocean. I don't really need that. Acapulco, cool, but who cares? His height as a function of time, h of t. That's exactly what that means. Could be modeled, blah, blah, blah. If you don't understand those words, here's the equation where t is the time. So somewhere along the line, maybe you could go h is height, and it's in feet. T is time, and it's in seconds. That's going to help a lot. Okay, so now every time I see h, I know that's height. Where every time I see t, that means how long, how much time. So let me get rid of all this. And so they don't tell you anything, but they do right here. This is all you need to know. How long did it take? So now we're going to start figuring out what are they asking? How long did it take for Jason to reach his maximum height? Well, that's weird. Where's his maximum height? At the top of the cliff. So, at 0 seconds. He's at his maximum height before he starts. So a lot of the word problems is really just trying to figure out, wait a minute, what are they really asking me? What was the highest point that Jason reached? Well, that's also kind of stupid because it was 480 feet. So far they haven't asked us anything crazy. Jason hit the water after how many seconds? Oh no. How are we going to figure this out? Jason hit the water after how many seconds? Jason hit the water. So what do we know? When he hits the water, well, wait a minute. What are we trying to find? So let's put this way. Find time, right? Find the time in seconds when Jason hits the water, right? A lot of this is about changing it from English to math. Find the time. Well, that's going to be in seconds. Also, you know what? Time is t. We already know that. All right, so that's the good part. So we need to change hits the water into math words. Hits the water. Well, water. What else do we know? Well, think of it, you know what? Let's get rid of the water. We have this. What does that look like? It should look like half of a parabola, right? And we got this over here. We want to know, what is this then? So this is where he started. This is our y. This is our x. What are we trying to find? Right? This is our t now, right? Time. We know we want to find the time. We want to find this time here. When what? What's happening? What are these y things? What are these y things? Oh, wait a minute. Wasn't that height? Wasn't that height? And wasn't this when y was 0? So we got, well, t, the time is 0, not the y. The y isn't 0. The y was what, 480? Which is, isn't that also the y-intercept? Oh, wait a minute. If that's the y-intercept, what is this? It's the x-intercept or the t-intercept. If I can find the t-intercept of this equation, right, then I've found what they want. I know what the t is when y is 0. Exactly. When y is 0. See, all of this doodling. Also, what do I know? Well, what is this called? What if I look at it a different way? All right, so t-intercept. So what was the function? Negative 16t squared. Negative 16t squared plus 16t plus 480. Now we can change it to x squared if that helps. And we want to find out when y is 0. Well, these numbers are big. I don't like big numbers. I'm going to tell you a lot of times in the easiest ones, the first thing you're going to look for is see if you factor it. See if you can factor it. When you factor, what's the first thing you look for? GCF. There's a good probability that 480 is divisible by 16. So let's see what we got. 480 divided by 16 is 30. What a coincidence. So I can pull out a, you know what? I'm going to pull out a negative 16. Right? So I've got x squared plus x plus, nope, minus 30. I pulled out a negative 16. Oh, that means this one has to be negative. Negative 16. See how I double check it? I don't move on and say, oh yeah, that's right. I want to double check it. Oh my goodness. Now how easy is this? Now we've got a GCF. We've got an x squared. We've got x minus, let's see, 30. What about 6 times 5? Because 6 and 5 are 1 unit away from each other. So we got 6. We got 5. You just want to make sure this is, if this is a positive 5, negative 6. So that gives you a negative 1, which is what we want. So x equals 6 and x equals negative 5. See how this is putting everything together. But wait a minute. X, and remember it was actually t and t. What does the t stand for again? Time. So negative 5 seconds. That doesn't make it. Now it makes sense, right? If I could go back in time, but you know, parabola is just, this is just an equation, but this doesn't exist because we don't have negative time. So this is called a, I forget what it's called, but basically it's not usable. T equals 6 seconds. And that's pretty much how you solve a quadratic function. I'm going to do like 3 or 4 of these videos with a couple of different ways to do them and what you're looking at, what you're trying to find. Let me just double check that there isn't more on this content that this was doing. Yeah, I'm going to use the next one. So watch the next video. The same idea. You're trying to find out what to find and what everything means and change it to math words. And that's the hardest part about all of this. This is your level 4. See you next time.